DNA as well as act as a cofactor in certain biological reaction. Important role in aiding rapid cell division and growth, such as in infancy and pregnancy. So this is the most vital function of folic acid for us, for the adults. So we need this folic acid to synthesize DNA, to repair DNA, so DNA repair and so on. We keep having DNA damage and repair in our body as we speak. It's not going to stop until we die. And the essential part of this folic acid is for the infancy and pregnancy. For those women in pregnancy time, you need to have this folic acid in in a in sufficient amount to prevent any problem during the to prevent any problem to the baby and during the pregnancy. So children and adults both require folate to produce healthy red blood cell and prevent anemia. So what are the vitamin B that also can prevent anemia? And I call Evain. And you recall my lecture from yesterday? Evain. Hello, can we have Devan? So Devan's not. I can see your name here, but if you're not answering my question, I will consider you are not you are absent. Devan. So I think we lost Devan. How about Lim Yue? Lim Yue. Hello, Lim Yue. Did you did you talk, Lim Yue? I couldn't hear you. Just a second. I think there's a problem with my connection. Just a second. Can you guys hear me?
Yes.
So can
Yes,
I?
I can hear.
All right. How about Lim Yue? Can you hear me? Devan.
I think she's having a mic problem.
How about Devan, sir? I've been lagging. Lim Yue. Lim Yue, you can hear me, but I couldn't hear you. How about I just call Marianne? Marianne is sweet.
Yes.
All right. So yeah, can you answer my question? What are the type of vitamin B that can prevent anemia?
I think it is vitamin B6.
B6. Sure. What's the name of vitamin B6? The active form?
Pyridoxal.
Sorry.
Pyridoxal triphosphate.
Yes. All right. That's correct. Thank you very much. Okay. Let me continue. Some of you said here you can hear me, but I couldn't hear you. Anyway, let's just continue. All right. Yeah. Both children and us as adults require folate to produce healthy red blood cell and prevent anemia. So that's the vitamin B6, the reduced phosphate. How can we get this vitamin B9? We can get it from yeast, lentils, beans, leafy vegetables such as Brussels sprouts, spinach. So uh, this list contains high amount of vitamin B9, folic acid, but uh, there's some other food sources as well. But these are the one that contain high amount of vitamin B9, like Brussels sprouts, spinach. Brussels sprouts is very not many people like it, and in Malaysia we don't used to eat Brussels sprout. people in European country, in American, they used to eat Brussels sprout. It's quite bitter. It's like our, Perrier. If you know Perrier, I don't know what's Perrier in English, but it's kind of like tastes like Perrier. It contains a lot of vitamin B9, folate or folic acid. So the deficiencies during pregnancy may cause uh, neural tube defect. Neural tube defect is the part, it's the back part of baby is not properly, what we call it, developed. When people have deficiencies in folic acid during pregnancy, and at one point, if that that individual uh, didn't take enough vitamin B9 and folic acid or folate until it deliver the baby might have this neural tube defect because the back of the baby and the spine is not properly developed. So it also affect the defect of the brain as well as spinal cord. So normally we can see its spine and spinal cords not developed properly. So this is going to be a sorry, a huge medical condition for the baby later on. So elevated level of homocysteine, which can increase risk of CVD and renal dysfunction. This also a very serious medical condition, and low fertility. So for those you know, the ladies, when you get married after that, planning to get pregnant, to have a baby, please make sure you take in account of this vitamin B9. It's very important. It's extremely important for those, especially get pregnancy or for the babies to have babies. All right, next vitamin B12, cobalamin. Cobalamin B12 is a generic descriptor for all carotenoids. Coronet, which is compounds containing cobalt-centered nucleus. You can see here deoxyadenosyl. This is one of the example of coronet compound. Current compound, you can tell this compound is coronet compound when you have cobalt and cobalt-centered coronal nucleus. You have cobalt in the middle of this, complex molecule here. This is the most complex vitamin. If you can see that the structure is complex, more complex than the rest of the vitamin that we already discussed. It's very complex. So in human, there are two metabolically active enzyme cobalamin form is methylcobalamin and adenosylcobalamin. This is not found in fruit and vegetable. So that's why you need to eat protein containing food in meat, fish, because these are the best source for you to get vitamin B12, methylcobalamin, and adenosylcobalamin. It's not going to be found. You can find this in fruits and vegetables. So hence, you need to have a very balanced diet, vegetable, protein, carb, and so on. Contain 4 vitamins. Vitamins is the term for the active form of this vitamin. Vitamins. First one, cyanocobalamin, the most common synthetic supplement form of vitamin B12. Contains cyanide, but in a very small amount, because the name is cyanocobalamin, contains cyanide but a very small amount. It can easily be converted to its active form, methylcobalamin and adenosylcobalamin. We will discuss how we can convert this cyanocobalamin to its active forms. And the vitamins number 2, hydroxycobalamin. Hydroxycobalamin, unlike cyanocobalamin, hydroxycobalamin is a natural type of vitamin B12. Cyanocobalamin is a synthetic supplement vitamin B12. Hydroxycobalamin, natural type of vitamin B12, can be produced by bacteria in the GI tract from food source. So I've been, talking quite length yesterday about the importance of the bacteria, our gut bacteria. So this is one more example of how important this bacteria is. So in order to produce hydroxycobalamin, we need to have our gut bacteria in healthy condition. Hydroxy B12 is readily converted in the body into the active form of adenosine and methylcobalamin. So, ability to bind cyanide increases detoxification by converting cyanide into less toxic thiocyanate. So, if you have, let's say, you've been, exposed to cyanide, you have cyanide in your body, so you need this hydroxycobalamin in order to detoxify cyanide by converting that cyanide molecule into thiocyanate. And number three, the vitamins number three for this B12 is methylcobalamin, and number four is adenosylcobalamin. So this methylcobalamin and adenosylcobalamin are two vitamins which we call it active form that play a role in your body. These, the first and the first two, cyanocobalamin and hydroxycobalamin, is not yet active form. When you get in these two compounds in your body, later on these two will be converted into its active form, the form of methylcobalamin and adenosylcobalamin. Generally considered the preferred form of vitamin B12. This active form of vitamin B12 works with several enzymes to synthesize amino acids to produce red blood cells, DNA repair, DNA synthesis, assists with other important physiological processes. Well, there's lots of other, process that need this methylcobalamin and adenosylcobalamin. The body can interconnect between the two compounds. So I hope you can memorize these four vitamins, which one is synthetic, which one is natural, and what are the active form in your body. Okay. So for example, cyanocobalamin, you need to know that what is cyanocobalamin, is a synthetic supplement or contains cyanide. Okay. And what is hydroxycobalamin? It's natural. How do we produce this hydroxycobalamin? By gut bacteria. All right. So what's the function? One of the function of this hydroxycobalamin is to detoxify cyanide. And then what's the most preferred active form? Methylcobalamin and adenosylcobalamin, and the rest of the function for this vitamin B12. Right. So again, going to simplify important here: proper nerve function, production of red blood cell, metabolizing fat and protein, prevent anemia, DNA reproduction. You can get, as I mentioned previously in the previous slides, you cannot get this from fruits and vegetables. You have to, to eat fish or animal product in order to get this vitamin B12. For those who are vegetarian, you need to have vitamin B12 in the supplemented form, in the form of cyanocobalamin, because I cannot say that it's wrong to be a vegetarian. It's not wrong to be a vegetarian. No, uh, going to. I'm just telling you that if you are vegetarian, you need to have vitamin B12 in the supplemented form. All right. Okay. And the deficiencies can have anemia, because this vitamin prevent anemia. When you lack of this vitamin, you can have anemia, nerve damage, hypersensitive skin, and elderly often have trouble in absorbing this vitamin. But this is not the deficiencies. This is why the elderly have problem in have a lack of this vitamin in their body, because the body, when you get old, it's very hard to to absorb this vitamin. That's why as we get older, we need to have the vitamin B12 supplement in the excess dose. So that's why, as I mentioned yesterday, in for vitamin C, same goes to this vitamin and other vitamin too, that you have to get this vitamin in supplemented vitamin in excess doses, so that we hope that our body can absorb some part of it, right? Okay, we're done with the vitamin B complex, and now you should know all the individual vitamin B in the vitamin B complex family, from vitamin B1 until vitamin B12, thiamine, uh, cobalamin, pyridoxal phosphate, niacin, nicotinic acid, folate, folic acid, and so on. All right. So we move to the next vitamin in the group of water soluble vitamin, which is vitamin C, ascorbic acid or L-ascorbic acid. This is by far the most famous vitamin of all, because of the antioxidant properties. Ascorbic acid toxic to viruses, bacteria, and some malign tumor cells. Okay. Because all these virus, bacteria, all these tumor, they produce free radical. They cause radical damage, oxidative stress in our body. So when you have enough antioxidant, you can combat these, especially virus and bacteria. So that we can kill that. We can kill the viruses and the bacteria. Display antioxidant property. This is the most famous function of vitamin C. It was discovered back in 1912, and not until 1928 this vitamin get isolated. And 1933, about 20 years later from its first discovered, was the first vitamin to be chemically produced. Because of the the importance of this vitamin as an antioxidant, the researchers, so the pharmacological industry, working hard to produce this vitamin chemically, synthetically. Most animal and plant capable of synthesizing vitamin C from monosaccharide. However, we as a human cannot synthesize this vitamin due to mutation in our body at the point of enzyme L-gluconolactone oxidase. All right. So animal, yes, we mammal, but we cannot synthesize because of this enzyme has been mutated in our body. We don't have this enzyme, so that we cannot synthesize vitamin C. And most animal and plant, especially, they have this enzyme in the non-mutated form. So that is why this most animal and almost all plants can produce vitamin C. So what are the function for this vitamin? The first, the most, the most reported, most documented function for this vitamin C is protect our body from free radical. How your body can get free radical from? Nur Ain Shuhada. Do we have Nur Ain Shuhada? Nur Ain Shuhada, can you hear me? All right. So can you tell the class how our body can expose to free radical?
Sunlight.
Sunlight. All right. And, anything else? There's lots of things can produce free radical in our body. What's the most you know what is the most metabolic pathway that constantly produce this free radical in our body? Ain Shuhada. Dah hilang dah. Nur Ain Syuhada. Nur Ain Syuhada. Where are you?
Is it oxygen?
Oxygen. How the oxygen can produce free radical in our body?
When there is a split reactive oxygen happen in our body.
Sorry?
When there is a split occur
Sorry?
of oxygen, split reaction
Split
occur in our
reaction.
body.
Yes, what type of metabolic pathway that can produce this free radical constantly? We are biochemists. We know that you've been learning all those metabolic pathway that we have in our body and living system that constantly produce free radical. How about can I ask? Check again. Adib, are you here, Adib? Adib, are you here? Adib, especially if I call your name and you don't answer my question and you don't respond, I will consider you are absent. All right. That's why you need to pay attention to my lecture. Adib, are you here? I can see your name in the list. We have 43 people in this meeting. So we have 42 students. So Adib, I consider you are not around. All right. So Adib's not here. How about Diana?
Yeah, I'm here.
All right. So can you tell me so what how our body can expose to this free radical damage?
I think all I know is from external sources.
External resources. How about internal resources that we constantly produce
Um,
every second in our life until we die?
reactive oxygen species.
Yeah. From
Sorry.
from what pathway?
Um,
You learned this before in carbohydrate metabolism.
I'm not quite sure.
Okay, thank you very much, Diana and Ain. All right, so if you recall back in your lesson, your lecture in carbohydrate metabolism, when you know during the electron transport chain, can you recall your body keep producing this free radical, all right? So because of our body have can produce their own defense mechanism, we can combat this free radical damage that produced from the electron transport chain. Electron transport chain is not 100%. It's not 100%. It's not working properly 100%. Some of these electron and oxygen species get what we call it. I couldn't find the words. We have leak of this hydrogen and oxygen superoxide during the electron transport chain. But we have the mechanism in our body produce the glutathione. If you recall back, glutathione and GSSG, GSH can combat this free radical damage that being produced by our body. But if you exposed to high concentration of free radical, you need uh, external helps from this vitamin C, vitamin B, and so on. All right. But the most common source of free radical in our body is from electron transport chain. Okay, the next functions helps from connective tissue that hold your bone, muscle tissue together in form of collagen. That's why for girls and ladies nowadays, there's a lot of uh, you know supplement. There's a lot of stuff that being selling in the market now that telling you that you can uh, what we call it anti-aging in the form of collagen, vitamin C injection. I don't know. I haven't found any scientific report that saying they have done the animal testing or for vitamin C injection. You know, I don't know if it's really work or not. Some show that it works, but in how how safe is it? I cannot tell you. But anyway, if you are decided, especially ladies, if you decided to have a vitamin C injection in your face or in order to uh, to have anti-aging properties, in order to get the collagen in your body, make sure you do your research properly before you decided to take the vitamin C injection. So the next, aiding in wound healing because of the function of this vitamin C forming connective tissue. It also can heal wounds, aid the body in absorbing iron from plant sources. So when you take vitamin C, you can increase your body in absorb iron about 30%, if I'm not mistaken, and then helps to keep your gums healthy. This is all related to connective tissue formation in form of collagen, bones and muscle tissue. Help to fight infection, all right, prevention heart disease and prevent some form of cancer. You can, I just hide this slide here because this is going to be showing you how these two vitamin C and vitamin E. Vitamin E also can act as antioxidant. So this is vitamin C as antioxidant. Ascorbate is an active form of this vitamin C to combat free radical. Oxidized vitamin C in the form of dehydroascorbate. Dehydroascorbate with the help of the catalyzed reaction by dehydroascorbate reductase. You have, I just mentioned GSH, GSSG to help you to produce oxygen and as antioxidant to combat free radical. So that's why you need vitamin C. But with vitamin C, without glutathione, you cannot have your antioxidant defense mechanism properly. So you need to have both vitamin C, GSH. This to this the reaction that can generate superoxide and other reactive oxygen species. You can do for yourself, and how the ascorbic acid can combat this superoxide and reactive oxygen species. You have this all reaction here. Ascorbic acid helps to neutralize this superoxide and ROS. So, sources of vitamin C: citrus fruits, tomatoes are the best known sources. Can have this vitamin C from guava, broccoli, cantaloupe, and so on and so forth. You can read by yourself, by your own. And the deficiency can cause weight loss, fatigue, joint pain because the joint, the cartilage is not strong due to the lack of vitamin C. A long time ago, uh, you can have scurvy. It's very common, but not at the moment. Reduce resistance to cold and infection due to virus defense mechanism. and bacteria, slow healing wound, and fracture bone. So when you lack of this vitamin, you can easily fracture your bone because this vitamin helps in maintaining your bone mass and helps in uh, f- you know increase the wound healing. This vitamin C, however, has been reported to have side effect for some people, not all. Some people, if you take vitamin C in excess, you can have nausea, abdominal cramp, and diarrhea. But these effects are due to the osmotic effect of an absorbed vitamin C passing through the intestine. All right. So because nausea, abdominal cramp, when you take too much vitamin C, I've been taking vitamin C 1,000 milligram every day or every 2 days. But luckily for me, I don't have this side effect. Maybe because 1,000 milligram or 1 gram of vitamin C is not that much. It's not a lot. I haven't tried above that 1 gram of a dose of vitamin C, but maybe this is because osmotic pressure and absorbed vitamin C. Can you imagine when you take something in excess that not being absorbed by your body, it will go pass through your intestine to your gut, right? In the gut, there's a lot of thing in the gut. You have your gut bacteria. Sometimes vitamin C is not food for your gut bacteria, so it can cause diarrhea, uh, abdominal cramp, and nausea. All right, we're done with water soluble vitamin. So we have vitamin B and vitamin C as a water soluble vitamin. Now we move to fat soluble vitamin. Fat soluble vitamin that have a long non-polar hydrocarbon chains or ring. This vitamin soluble mainly in lipid and oil, so-called fat soluble vitamin A, D, E, K. We in Malaysia, our teacher used to tell us that in order for us to really remember this vitamin by the adik, use the term of adik, A, D, E, K. Fat soluble vitamin accumulate in tissue and not leach out quickly as the water soluble vitamin. So that's why you cannot have this vitamin in excess, because it accumulates in your tissue. You can have toxic effect if you take this vitamin in excess. Excessive use of this fat soluble vitamin lead to hypervitaminosis due to delayed elimination rate. This accumulation of vitamin result in toxic effects. We're going to go through one by one for this fat soluble vitamin later on. Okay, these vitamins tend to be stored in fatty tissues, adipose tissue, and in the liver. They are eliminated slowly from the body because of the lipophilic character. Okay, vitamin A. First, vitamin A, family of fat-soluble retinoid. There are three forms of vitamin A important for health. Retinol, key player, can be converted to other forms, retinol and retinoic acid. Beta-carotene is a potent pro-vitamin A. Okay, retinol, retinal, retinoic acid, beta-carotene, pro-vitamin A. All right, vitamin A, carotenoid cleavage and storage. So first, beta-carotene is converted to vitamin A in the intestinal mucosa. So when you eat food contain beta-carotene, your body will absorb this molecule in the form of beta-carotene, and when it gets into intestinal mucosa, this beta-carotene will be converted to vitamin A. 90% of this will be stored in the liver, mainly as ester and retinol palmitate. Only about 6 months storage based from the studies that have been conducted by lots of researchers. Small amount in adipose tissue and blood. Most of this vitamin A can be found in the liver, 90%, and 10% can be found in adipose and even less in blood. How do we transport this vitamin A? So first, we need retinol binding protein to act as a transport vitamin A from liver in the blood. So you know that now when you take beta carotene, it's a pro vitamin A. When you come across the name of pro vitamin, meaning that this is not yet a vitamin, it needs to be converted into the form active form of the vitamin. So that's why we call it pro. When it's not being converted, it's not a vitamin yet. So this beta carotene, when you take from, for example, from carrot, from vegetable, um, it needs to be converted to the vitamin A in intestinal mucosa, and then it will be stored in the liver. So with how do this get transport to blood? By using, you need this RBP, retinol binding protein. Retinol binding protein is a transport mechanism, transport system that transport this vitamin A from liver and in the blood. Right. So the excretion of this vitamin A is very small amount in urine. That's why it's not readily excreted. The very small amount can be excreted in urine. So you have this is not very nice diagram here. So we have beta carotene, right? Small amount will be converted into retinoic acid, and most of this beta carotene will be converted into retinol. Or retinol will be converted into retinol, and then retinol is this all is a reversible reaction. Okay, this is how you convert beta carotene into the active form of vitamin A. What are the major functions of vitamin A in our body? It's not really readily broken down by cooking. Um, Vital to good vision, retinol is oxidized to retinol. It's combined with protein opsin to form rhodopsin. Rhodopsin is the active agent which converts light signal to electric impulse that the optic nerve transmit into the brain. So this is how vitamin A. This is the role of vitamin A for our eyes. People been said that okay, eat carrot is good for your eyes, right? So this is how it can produce good effect to your eyes by this. First retinol oxidized to retinol. First you have retinol, then you have retinol, and then combined with the protein opsin to form rhodopsin. Right? So this rhodopsin active agent convert light signal to electrical impulse, transmitted to the brain. So by taking enough vitamin A, it can prevent night blindness, also antioxidant in the form of beta carotene necessary for healthy skin, hair growth, keep mucous membrane healthy, promote bone development, support immunity in the form of retinoic acid and carotenoid. So when um, if for those who have like baby brother or baby sister, if your niece or nephew, baby niece or baby nephew, if you or your parents or your sister or your brother have babies, if they feed the babies too much carrots, the skin of the babies will turn into kind of yellowish orange color. It's happened to my sister. When she had a baby last year, and then suddenly she thought that the babies had jaundice, but the babies is already 6 months. Normally jaundice is for the first 1 month of the baby life, and after 6 months or 7 months the baby start eating solid food, and developed kind of orange and yellow skin color. And then she took the baby to see a doctor, and the doctor asked her what you've been giving your babies, and my sister said, every day carrot blend with some puree, something, and because she's been feeding the baby with too much carrot almost every day. That's why, because it's not readily excreted, it's been stored in your body, so it can it gives you it kind of like sign of that vitamin A excess. So the doctor said, okay, you have to stop giving carrots to the baby, or until you see the reduce of the color of the skin. So that's why you cannot eat too much, especially for infant and baby, because the body is still developing, the organs still developing. You cannot process this vitamin properly yet. All right. So sauce, liver, milk, egg yolk, carrot, of course, green leafy vegetable, orange, colored fruit. Colored fruits contain lots of carotenoid. Deficiency, more obviously, um, deficiency system other than vitamin, uh, night blindness, leading cause of blindness in third world countries, cell keratinization, dry skin, xenophalia, reproductive failure, abnormal skeletal development and maintenance. It goes, side by side with vitamin C. When you don't have enough vitamin C and vitamin A, you don't have, very good bone formation and skeletal muscle formation. Even this immune system dysfunction. And what else? So the toxicity, vitaminosis A in humans, self-medication and over-prescription. This was happened to my niece. You know, Too much carrot in the diet. Symptoms: skeletal malfunction, spontaneous fracture, birth defect, miscarriage, decalcification, joint pain, fragility, dry, itchy skin, hair loss, liver damage. Why liver damage? Liver damage because you need liver to process this. The liver is the central metabolizing organ in our body. Almost everything will go to liver first. In the liver will, our liver will process all this stuff before being, give to blood and to other part of the body. So when you have too much vitamin A, it can affect the liver and can cause liver damage. Overconsumption of beta carotene from food source may cause skin to turn yellow. So yeah, this is what happened to my sister's baby. But it's not harmful, you know. If been given for short period of time, it's not harmful. Okay, but if it's for a long period of time, it can cause all these symptoms. Okay. Right, next, vitamin D. Vitamin A, we've done vitamin A, now vitamin D, a group of fat soluble corticosteroid. In human, the most important compound in this group are vitamin D3, known as cholecalciferol, and D2, ergocalciferol. That's, that's a mechanism that you have to remember later on. The natural form of, for animal and man, for us, is vitamin D3. Cholecalciferol can be produced from cholesterol and 7-dihydrocholesterol. So we can produce vitamin D3 in our body from cholesterol and 7-dihydrocholesterol. Alternative, vitamin D2 can be produced from ergosterol. Provitamin D2 can be found in yeast. Okay, so also called sunshine vitamin. We don't have problem in our country, in Southeast Asia, temperate country. We don't have a problem to get vitamin D because we have lots of sunshine every single day. So the body can make it when exposed enough to sunlight. Vitamin D from the diet or from skin synthesis is biologically inactive. A protein enzyme must hydroxylate it to convert to the active form. This is done in the liver and in the kidney. So first, what we get from our diet is not yet active. It's biologically inactive. A lot of stuff that we get from our diet is not yet biologically active. Like vitamin A, we have to convert it in the body to become retinol and so on. So does the vitamin D. You need to convert it into the active form of this vitamin, and it can be done in liver and in kidney. This is how our body metabolize it. Vitamin D metabolism, uh, following dietary intake when you eat something that contains vitamin D, or even it can be synthesized in epidermis of skin when you're exposed to sunlight, UV exposure, both from dietary and from skin. Vitamin D enter the circulation and are transported to the liver by vitamin D binding protein. So first of all, you eat or you synthesize um, in your skin by sunlight. These two forms of the provitamin D will enter the blood and get transported to the liver by the protein called vitamin D binding protein. All right, you know that you need transporter to take this to the liver. Now, it's already in the liver, hepatocytes, the liver cells, right? This vitamin D is hydroxylate to form 25-hydroxy vitamin D, or we call it calcidiol or calcipediol. Okay, so this is in the liver. What happened is that this vitamin D that we take from diet or from exposed to sunlight will be converted hydroxylate to form 25-hydroxy vitamin D, calcidiol, calcifediol. You can give the answer as 25-hydroxy vitamin D. You can give the answer in the form of calcidiol or calcifediol. All right. And then, how about in renal? We know that this vitamin D is metabolized in liver and renal, right? So when your body converted this vitamin in the form of calcidiol, the renal enzyme 25-hydroxy vitamin D 1-alpha hydroxylase enzyme eventually catalyze a second hydroxylation reaction that converts this 25-hydroxy vitamin D to 1-alpha 25-hydroxy vitamin D, or to make things easier for you to remember, is calcitriol. Okay, calcitriol, the second hydroxylation process gives you calcitriol. Okay, again, first, you take from diet, exposed to UV, vitamin D binding protein transport this to the liver. The liver hydroxylate, the first hydroxylation reaction in the liver convert vitamin D to calcidiol or calcifediol, and then it goes to renal. And this enzyme here is quite a long name here, catalyzing second hydroxylation reaction, converted that calcidiol into calcitriol. Right. So this diagram here I prepare here for you to make things easier for you to understand the process from the skin or from the diet to the liver to the kidney. Right. So when you have calcitriol, this is the active form of the vitamin D. All right. Major function in the body: calcium and phosphorus homeostasis. You know that vitamin D very important for our bone. Calcium and phosphorus absorption in small intestine. Without vitamin D, your body cannot properly absorb calcium and phosphorus. Vitamin D helps your body to increase the absorption of calcium and phosphorus. Calcium reabsorption in kidney and bone, maintain blood calcium level. Bone formation stimulate calcium uptake for deposition as calcium phosphate. Hormones regulate gene expression and cell growth. These are the major function of the vitamin D. Hormone, cell growth, bone formation, maintaining blood calcium level, so on. Okay, again, same with the previous diagram. It's up to you which one you prefer. Same here. 7-dihydrocholesterol, UV, cholecalciferol, vitamin D3 from diet, liver, first hydroxylation reaction, and then goes to kidney, second hydroxylation reaction, then producing calcitriol. Calcitriol is active form of vitamin D. What it does then, increase calcium absorption, increase bone calcification, increase bone reabsorption, and decrease renal calcium phosphate excretion. Okay, this is the major function in the body. Again, it also happens to involve the parathyroid hormone. So when you have low blood calcium level, increase PTH production, release calcium phosphorus from bone, normal blood calcium level, decrease calcium excretion, so on. You can read as is mentioned in previous slide as well. All right, I think we're going to finish up vitamin D. We have 1 minute left. So vitamin D, where can you get vitamin D from? Commonly found in fish, liver oil, as well as egg yolk. The body synthesizes vitamin D in the skin through reaction of ultraviolet on 7-dihydrocholesterol, and deficiencies in vitamin D known as rickets and characterized by bone softening and malformation. You can see these unfortunate kids here. Child with rickets, and 2 years after treatment, you can treat this deficiency. You give vitamin D treatment, and the bone can properly form. How about the toxicity? Because of it's not readily excreted, we can have vitaminosis, vitamin D in human, calcification of soft tissue, lung, heart, blood vessel. What does it mean by calcification? Too much calcium, in soft tissue. You have to have a proper amount of, dose of calcium, level of calcium in your lung, heart, blood, bone, and so on. If you have too much calcium, we call it calcification of soft tissue. It can cause hardening of arteries. You know what's going to happen when your arteries hardening. It also can produce stone formation in kidney stone. All right, so make sure you don't have too much vitamin D. It does not occur from sunlight or diet. Normally occurs from supplement. Because why? Normally, how long does it take for you to expose to sunlight? But still, the amount of vitamin D is not going to be too much for your body. So does with the diet. When you eat a lot of, fish, for example, contain high amount of vitamin D every day, it's not going to give you toxicity by ingesting too much vitamin D. Normally goes from the supplement. That is why, in general, we are not recommended to take vitamin D supplement. For those who live in you know who live in country where you not get enough sunlight, for example, during the winter season, or in countries in regions such as Arctic Circle, Antarctic. Sometimes they don't have sunlight for 3 months, 4 months, 5 months, even half a year. So that people from that region is recommended to get the supplement, a vitamin D supplement. Okay, but not for us. For us, we get too much sunlight. Even we try to hide from the sunlight. Okay, I think we are going to continue E and K next week. All right, and before we end our lecture, any question from you? Any question, guys? Sleepy?
No question.
No, doctor.
Yeah. All right. Just again, sort of a reminder for all of you. When I will like usual, I give the link, Google Meet link to your friend, and your friends, will share with you all. And then if, for example, I said that the class will start at 10 or 9, please join this meeting before class starts. All right. So that I don't have to, to keep accepting you to join the class and interrupting my lecture. And all of you also, please pay attention. I will randomly call names and ask question. If you do not respond to my question when I call your name, I will consider you are absent, even though your name is in the list. Okay, for today, almost all of you, except for Adib. Adib didn't respond to me, so I will consider Adib absent today. I'm not going to call all of you, I just randomly, but please pay attention to my lecture. All right. So that's all for today, and then have a nice day. Stay safe, and see you next week. All right. Thank you very much.
Thank you,
Kita
Doctor.
ada
Thank you, Doctor.
Thank you,
Thank
Nata.
you, Doctor.
Thank you very much.
Thank you, Doctor.